Hi, my name is Roland, and the last few months I was building my AC Powerwall, and today is today when everything is coming to a close. In this episode we are talking primarily about hardware, but not so much about what is built into the Powerwall. This you can already see in previous episodes. It is all about the performance. So I will show you logs how the Powerwall was functioning and how much it helped us to save money, energy, export and whatever. The second topic is the change from prototype controller to a real one, and this is what I will show you next. Okay, let's see some data first. I want to show you the latest data from the solar systems, and this here is now the new battery. You see, we started in the first months with about 208, then 200, 247, and now last month was 282 kilowatt hours, which we captured with our chargers. And so why is it so low here and then slowly starting going up? So the reason for that is that September, October is here for us is the main monsoon peak, and yeah, it was basically raining 10 days in a row, and I will show you later some logs from that. Then October is still same thing, right? October, November, that period the weather is improving, so the output is getting better, and now the last November, December period was already beautiful weather. We have now winter time and blue skies basically every day. You know, I've changed the CT because we had a demand problem. We could not use so much energy in our apartment every night, and now also the weather in the night is actually nice, so the air conditioner is not running so much. So yeah, that improved. The last few days were a little bit better, but still, you know, Thailand is a closed country for tourism at the moment, so it's mostly weekend tourism, and yeah, so we still have too much energy during the week typically. Okay, let's look how the months look like. So you can see here, this is August, we have a very good total, and then September is 25% less basically the next month, and then yeah, now it's getting already better, but the days are shorter now also, so yeah, it will stay somewhere in this area, 1.8 megawatt hours generation in 1 month. The indicators for the batteries is here. You see, before we had the battery installed, the ratio of solar to used energy at total was somewhere around 40, then also just 35%, and with the battery it then jumped now to 50. This is the extra solar energy which we can store now in the batteries, which is shown here. And the ratio between self-consumption of total generation should also have improved, of course, but this is of course also dependent on how many guests we have in the resort. So if we can use already a lot of energy during the daytime, or if it's trying to export and it has to store in the battery. But it went up. We are now kind of constantly around 70%, and 70% we only have usually during the high season when there's a lot of gas here, and then it will drop to about 60%. So also there 10% improvement. Let me show you the first one. What one is this? Yeah, this is a September log. You see, this is a log from the bad weather. This is the available energy from our solar output, and it's just, you see, 1000, 2000 watts almost all the day. Then afternoon there must have come some sunshine in between the clouds. And this you see also here in the charger curve, just one charger all the way somewhere here, and then it went bright and both chargers have been activated. In October it's already better. You can see this is a cloudy day, but you can already kind of imagine the solar generation curve when it's not disturbed by anything. And this is a very dynamic situation, and it shows actually how nicely the battery is following the available curve, export curve. And you see here one charger, two chargers, then down one charger. And if you look at this curve here and then look at this curve here, you can see the similarities. So you can also really see that the Powerwall is trying to follow the curve of the available energy we have. And this one on the down is just what is left over, and this is just, you know, some noise. Okay, last one. This is now a situation. Here you see already available energy very nicely. This is a beautiful blue sky day. We have the typical solar available curve, and the chargers here. In the morning one charger, and then quickly going on two chargers, staying on two chargers all the day until the battery is full, and then just topping up a little bit. Then you see here this big spike also on this one down. This one is inverted. So this spike here is an electric vehicle charging an Powerwall charger. You remember the controller was a prototype build. This is it. This is the Arduino Mega, and this was running our Powerwall for probably 2.5 months. And there were several problems with something like this, of course, and mostly they had to do with all this kind of stuff here. Jumpers, broken jumpers, then connectors. You just need to blow on it and it will already disconnect. I had to extra buy a shield so that I could solder all these jumpers then also for the digital pins of the Arduino, otherwise it was just a mess, you know. So we went from this kind of board. It's just a prototyping board, PCB, with soldered wires. Then after about 2.5 months to the first version of a real PCB, a designed one. So I did a design in EasyEDA, and this was version 1. But not too much later I already started with the version 2. And the version 1 was used now the last 2 weeks. It was kind of showing proof of concept. There was one hardware change with this one coming, and this was an additional second display, a small OLED display which is showing now the modes, and that a bigger LCD display is only showing data, so I have more space for showing data there. And then on the version 2 board I included then the copper plane for the ground plane on both sides, so every unspaced use is a copper plane, except here where the ESP module is, there is no copper, so that the Wi-Fi signal can also pass on the back side of the board. Otherwise, yeah, there have been one major change with here you see this is a last version 1 controller. The version 1 controller was still using these MOSFET units here, and on the version 2, you will see later when I show you the other board, it is included already on the board. So with the version 1 board there came a big software upgrade also. On the prototype I was writing about 70 revisions of software, and because the prototype was based only on one display, I had to basically convert all the program for using 2 displays, and so it was also software redesign, and there have been now 12 revisions of software code written for the first controller, and that code will also run now from today on the version 2 controller, which will be built into the controller box today, into the Powerwall. I have to say the difference between something like this and this is of course massive. How stable it is running, right? The code is running is that's really major difference. If you are working with microcontrollers, you know that they can occasionally reset, and it of course depends on the complexity of your project. And we are using 2 communication ports for Wi-Fi, for Modbus, and we're using the serial port, the I2C port, and the SDI. So there's a lot of different communication going on here, and you have to of course bring that together into one functioning code, of course, and that is for itself not easy, but if the hardware is kind of unstable, it is complicating the issue much more. But it's working very well. The version 1 controller was working for 2 weeks inside the Powerwall, and no hardware issues. Of course, software we will talk in the next video, and that is a completely different beast, and you will see that once you go from internal to external using Wi-Fi, internet and servers, something like that, that can make really a lot of mess. But it's done, it's working, and yeah, you can have this board if you like. I have spares of version 1. If you would like a version 1 board, I would give this as a free giveaway, but I would have to charge you for your shipping. You could either, of course, run a Powerwall, because it was doing that quite good, or use it as a kind of training shield. If you're just starting with programming of the Atmel microcontrollers, you don't need to use all of these components which are inside here. So, but if you have the Mega Pro, you can just choose. You want to do relays, you want to do SD card, you want to do the internet, and you can use this as a training device, as a shield. And of course, you only need to follow the pin list of pins, and well, that's it. So this one, because the version 1 board I will never build again, but if you want one, it's a free giveaway, just shipping cost. If you would like to have a version 2 board, I can send it to you as well. So the board alone, bare board, you could have for the manufacturing cost. So when I manufactured it and the shipping to me, that was about $5 US dollars per one board. So including that and a little bit for my effort to go to the post office and this kind of stuff. You can have this kind of board without anything for $8 plus shipping, right? So $8 plus shipping for the bare board. If you would like it like this, so if fully assembled, this is the version 1, but I would just do it with the version 2. So a fully assembled version 2 board with all the connectors, resistors, capacitors, stuff like that. So everything was on the board plus the harnesses, right? The wire harnesses. And what would be complete would be also here the harness, including the 12-way switch, because they are kind of difficult to find. So if you want it like that, I would charge you $28 plus shipping. So for a pre-assembled mainboard plus the 12-way switch. And if you, the third option, would like it completely assembled, so all modules which are on the board and also which are connected to the board, I would send to you for $60. So all the parts are coming from my most favorite seller in Shenzhen, and so it's a, I think, very good price. $60 plus shipping, completely with microcontroller, with all the different breakout boards, clock, Wi-Fi, etc., etc. This would cost $60 plus shipping. This kind of controller, of course, does not need to be used as a Powerwall controller. Of course, it can be universally used for whatever you need it. If you like programming, you can basically take each of these components and do whatever you like with it. So I think it's a good opportunity to do something like this, and the price is, I think, very, very acceptable. So here we have them all three together. On the left, our prototype. This prototype was built into the controller for about 3 months or 2.5 months, and there have been about 70 software revisions written on this platform. So all the basic features, modes, etc. have all been implemented while this board had been in the controller. And as you can see here, this is the standard Mega, and the problems with this kind of setup is, of course, as you can imagine, all these wires, jumper cables, these DuPont connectors here. This is just, if you touch a wire somewhere, it will already start to disconnect. And this is already not original, as I have built it, because you see there is a shield built in between here. Original design, there was the Mega kind of plugged directly to the PCB here, and we used jumper cables going into these digital ports here, and there have been at least 2 broken jumper cables. So that's why I then ordered this kind of shield, so that I could later on directly solder those cables to the shield, and then the Arduino would be plugged in. So yeah, prototype bye bye. The next was the controller version 1. The controller version 1 was now built into the Powerwall for about 2 weeks, and yeah, it was running very nicely. And this one, and also this is the version 2 controller. So both of those boards are based on the Mega 2560 Pro board. So if you compare now this to this, you see, I think the Mega Pro is only about 1/3 of the size of the original Mega. So it's an embedded version, and it's just plugged here into these headers here and running the controller. And the controller is basically built like a PC mainboard, so you only have connectors and sockets on the board, and you just plug in all these components. So the version 1 still had these MOSFET units here used, the finished ones, and this makes it very big and clumsy. So that's why the version 2 was developed, and there's a few changes on the version 2, and one is the most obvious here. As you can see, these are the finished modules, and here everything is already on the board. And the other thing which you might only see when you look very closely, the version 2 has copper planes for ground. The version 1 didn't have it, and we have several additions, because the version 1 actually I planned it with an extra buck converter for the 3.3 volt to supply the ESP01, but you know, those measurements I took actually from this one, which I got here in Thailand, and when I got the other ones from China, they did not fit. So I scrapped that, because the Mega Pro is actually rated very nicely. 5 volts and 3.3 volts can supply 800 milliamps. That's a very good converters already on the board, so it's absolutely not necessary. Yeah, then on the version 1 I already had 2 I2C ports, because this version was running already with 2 displays. So the controller has now 2 displays. One is a small OLED display which is showing the mode, and that kind of gave me the chance to show a few more important values directly on the LCD screen on the bigger one. And the version 2 has 3 I2C, so 2 are used now for displays, and you could use it for anything else. Then analog extra input for the 16-bit analog to digital converter. We can already plug it in, because today the first time version 2 will operate the Powerwall. So also the Mega board, just plug it in. Yeah. That looks very clean. So what do we have now? We have all the connectors. We have the controller, microcontroller, then the real-time clock, the max module for the Modbus, then the 16-bit analog to digital converter, ESP01, and this is for the LED indications. The battery volt sensing is here, plus minus, and this is for the inverter current sensing. When the inverter is in use, the controller will show us how much amps, how much watt it is producing. 12 volt input for the indicators. The rest is directly connected somewhere at the controller casing. So relay module is there, and the switches, rotary encoder, etc. So whoever is interested to use this kind of controller, just give me a note, and the email address will be shown in the video, and then if you want it, you can either have just the PCB, bare PCB, or if you want it just with all the connectors, or also fully populated. Okay, so let's take it and bring it to the Powerwall. Okay, right here it is. The new board is in place. All the wires are connected, and you see here inside of the lid 6-way relays on the right, the main board, SD card reader. Here we have the big LCD, to the right rotary encoder, the small OLED display, indicator, switch and master switch. So let's close this up. Let's start it up. So here you can see now we have the small display here is just showing modes, and so it gave me an extra line there on the LCD screen to show some important values already on the first screen. You can see system connecting to the Wi-Fi. That takes about 15 seconds to connect to the Wi-Fi. Now connecting to the Blink server. SD card is ready, and this is now the first screen, mode number 1. Battery voltage coming up, and here is the state of charge. So, but now oops, I forgot to plug in the 12 volts. Oh, wait a minute. Oops, again. Okay, here you see. Also the LED indications are working, but you heard a click, and the click was the contactor for the inverter, because I just put a brand new real-time clock and it's midnight. So we have to set the clock, and this is working like this. We have here the mode selector, and the last mode, mode number 12, is the setup of the clock, and modes work like this. We have here the programming encoder switch, which you can press, then you enter some modes, and then you just turn what you need to change. So today is the 10th of December, 10/12/2020, and we have a time of around 13:45 it says on the inverter, so let's try that one. 13. And the setup is done. I can now turn back the mode to mode number 1. So modes are shown sometime with the A or B, and this just means that there's the A page and the B page here available. So the first page here you show charges, inverter, then battery voltage, state of charge, then the power readout from the Modbus, from the meter, the clock, and when I press again this button, it will go to the second page. So here we can see some other values which might be important. So second line is the phase 1, phase 2 and phase 3 readout. then temperature, etc. Battery, internet connected, the type of meter, and some debugging readout there. Oh, it works perfectly. The software is actually finalized, and this controller now should actually work with the software which is installed now, without any more further changes. Okay, let's go back and talk about some other details. So I cannot tell you more about the controller. The next part, the next video will show about the software, what was the software problems in testing, what was the biggest challenges, and there have been quite a few, and for those who know a little bit about programming of Arduino, might be some tips inside in the video which can help you if you kind of run into the same problems like I had. So yeah, thank you very much for watching today's episode. If you're interested in one of the boards, please send me an email. The link is at the bottom of the video now, and I can then send it to you. Okay, thank you also for watching other episodes. If you new to this, if this was the first video you saw, please watch some older videos about the building of the Powerwall. I see you in the next video then. Talk to you later.